Hi, I've got this script here which is designed to calculate the QV curve at a bus. I'm just going to go through and clean it up a little bit and show you how I do that. So the file is sort of 60 lines long, and it starts by setting up a few variables, defining a function. This section of code here calculates and saves all of the buses which are greater than 100 kV. But this selected bus variable isn't actually used throughout the rest of the script, so I'll just remove this section because I don't think it's useful. Now these are a bunch of variables which are set and used later on. They're actually the global variables, which is something that we could remove later on, but we'll leave them in and put them up the top. So if anyone wants to change these variables, they know where to find them. They're at the top. I'll initialize the case later. Put that down here for the rest of the code. Now this getData function was used as part of the code that I removed earlier, so I'll get rid of that too. The addMachine function adds a plant to a bus, and this bus number is a fictitious bus that we add later on. Then we add a synchronous machine to that bus. Synchronous machine is purely there just to change the voltage set point, really, by adding and removing reactive power as necessary, and we return nothing here. So what I clean up here is it's kind of hard to read what we're actually setting on this machine data to. I think a lot of these are the default values. I might be wrong, but I think they mostly are. So I'll only set the values that we actually need. I think this is 3, 4, and 5. Now I don't need to comment these any further. It's very clear that I'm setting the generated power, which should be probably 0. Yep. The maximum and minimum Q limit, which are the maximums and so on. I think these are the defaults. So if I set those, get rid of that. The pgen being 0. Yeah, no, it would be 0 anyway unless you set it otherwise, so that's the default. And the Pmax being 0. I mean, you really don't need to set any of those variables at all, but maybe I'll leave them in there because they are controllable with the variables up top. If I was doing that, I'd probably just put a default machine in and get rid of these. But we'll leave it as is. The next function, getNvar, changes the voltage set point. And it solves the case, returns the new reactive power output. Now we set the solution parameters each time through the loop. I think you could probably just set this once, and we might do it at the top, or even just after we load the case. Now the solution parameters 3, I had to look this up. It's setting the number of iterations to 60, so just to be clear. Now we're grabbing the machine data and I'd return it like that. So it's clear what we're grabbing, and that M bar value previously included the I error. Now here's the meat of the entire QV curve script. This section here, we initialize the case, set the solution parameters, create a new bus, test bus, and branch that bus to our target bus, which is where we're really running the study. Now we add a machine to that test bus, which is our synchronous machine, which will be providing the reactive power. We do some imports here, which I'll just chuck at the top of the script. Normally you put your imports at the top. Create a set of per unit voltages, and for each of these per unit voltages we'll get the corresponding reactive power value and create this var list and plot them. So the rest of the script looks okay. Now I don't have PSSE installed on this machine, so I can't really run through it, so that's about as far as I can go. But as a first cut, that's how I might clean up this script.